Hi, everyone. So today we're going to be looking at data and talking about actually analyzing data. So, how is it non neutral? Taking all of those pieces that we've sort of talked about over this whole entire unit and then seeing if we can sort of analyze and critique what that data is showing us. So, first thing I'm going to say is that in your notebook, you should have some papers that go through the same graphs and have some questions. I would strongly recommend if you are not in class for this and you are just watching this from home, that you are taking some time to press pause and thinking about these graphs on your own before I go into some of those details. So, first graph that we have here, NFL passing touchdown career leader. So when we are looking at these graphs, we have a couple different presentations here that we want to take a look at. So the first thing that you might think is, oh, I agree or I disagree with one of these graphs. But main thing is we're going through here is how would we talk about this data? How is this data being collected before we assume anything about it? Okay, so the data is being collected probably by observational, right? An observational study. We're just watching to see what happens and we're keeping track of those statistics. Would one set of this data serve a different purpose than another? So on our data on the left, we have NFL passing touchdown as our career leader. And then on the right, we have the NFL passing touchdown as career playoff leader. And you'll notice that that significantly adjusts the placement of some of these people on the list. So for example, if you really don't want to say that Tom Brady is the all-time best, then you might want to look at the data on the left. Okay, but maybe if you're saying I want to do more to show that Tom Brady is better, then you're picking the list on the right. I mean, whatever, right? So this is all based on just what specific games you're looking at. Okay, so could we find data that shows even this in a different perspective? Well, depending on what games we're looking at, maybe we plot a specific year, a specific season, right? So this is all based on if you're not super familiar with football, right? Playoffs is sort of like once you've made it through regular season. Think about it as sort of us doing our football games as we're working up towards state, right? Where you play a game and it sort of eliminates you, right? So this is just a way of showing data that shows something different based on what specific games that we look at. Here's another one that we have. So here's data that was very popular not that long ago, okay, showing that 5G wireless network caused the spread of COVID. So a 5G wireless network was making COVID spread. Okay, and this was data that was actually shown. And so they would present the graph on the left, which is 5G wireless towers, and then they would present the graph on the right. And people would look at this and see, man, those are so stinking similar. 5G wireless towers must be causing COVID. Now, some things to think about. How was this data collected? So, this data was collected by observational data, most likely, right? We're not controlling anything. We're just simply observing where COVID cases are and where the wireless towers are. Okay, maybe some type of sampling happening within that. Whose interest would this data serve? Well, if you are wanting to show that COVID is not an actual virus that is happening as normal viruses do, but that someone is actually causing them to happen, maybe through 5G wireless towers, I think the key here to understand is that this was not an experiment. An experiment means that we control something, and there was nothing that was controlled. So we cannot say that this is a causation. So that word caused up there is the dilemma here, right? There's a correlation between where 5G wireless network towers are and where the most COVID cases are, but that has nothing to do with one causing the other, but more the correlation is those are places that are more densely populated, right? So where we have larger density of populations, where people live closer together, or we have more people, we're going to see more COVID cases, and we're also going to see more 5G wireless towers. So there's a quick video on this that we can watch.
It made the rounds, helped by images like these, showing maps of coronavirus cases alongside maps of the 5G rollout. And initially, the similarity there does seem striking until you realise those maps also look like the ones of population density, which makes a lot more sense because that's correlation, not causation. Wi-Fi rollouts and virus cases will both be where there are a lot of people. In fact, lots of maps look like those maps. This one of Domino's pizza locations looks like a map of coronavirus. make sure Domino's Pizza isn't caught.
Okay, so again, just reiterating that causation is not the same thing as correlation, and correlation does not mean that there is a causation. So here's another graph that we can look at. So again, this would be a suggestion where I think that you should pause and take a closer look at this map and maybe see what you can consider. Okay, but this graph looks like it's showing, if we're just looking at this, right, we have three presidential candidates running in the GOP, and it's showing the percent of who is supported the most. Now, some things we might notice when we take a closer look at this: A, this doesn't add up to 100%. B, we don't know how this question was asked. So how those people are each getting more than adding up to 100%, we're not for sure on. But you'll also kind of notice, right, each of those pieces, it kind of looks like it's divided into thirds, and those numbers are not equivalent. So pieces to consider there. Whose purpose might this be serving? Well, maybe we don't want to show as much support for Palin as she's actually getting. Maybe the GOP is trying to dictate who they want to look better. How could this data be better presented? Well, it depends. It'd probably be really nice if we knew how this data was asked. Maybe people were just asked, which of the GOP candidates would you be willing to support if they ended up winning the primary? And you are allowed to select all, right? So maybe we need to see some type of bar graph that's just saying who would have support behind them. Right? There's lots of different ways. Maybe if we did have a pie graph, we would need to make sure we were actually asking a question that would add up to 100%. Okay, we also have an article in here. So again, you might want to pause and go in and actually read this article. Take a little bit of time to do this. But one of the things that I think jumps out for my students as they start to go through this article is just the very difficult wording in here. When we are looking at actual research studies and we are reading words around them, it can be very complicated and complex, and students give up right away. So they get through these first couple sentences and they go, nope, I can't read that. But some things that we might want to notice or we might be able to understand, right, is we should be able to understand things like here, right? The sample in these early COVID results were 1,000 healthy adults. They're 50% male, which means we should assume 50% female, and the majority of them were white. They were ages 18 to 55, and the median age was 35, so it looks like it was even on the younger end. Okay, so I mean, we're able to see who the sample was. It was non-randomly selected, so what does that mean? Right? There's pieces that we can talk about with what that's happening, even though we might not understand all of the words in between here. So one of the things that I think is important to understand is that while we might look at an actual research study and not be able to understand every single piece, there are definitely pieces that we can understand. Sorry about that. Okay, so our first thoughts when reading this article might be that this is way too difficult. Okay, but there might be parts that we can understand. There might be parts that jump out at us that say we can do something with this. Okay, so that sample size, things that we know would be important to us. Here's a graph that was shown. So I'm trying to show both sides. So this graph was shown of Democrats who were more likely to agree with the court's ruling on Terry Schiavo. Okay, and when we're looking at this, there's some different questions that we might want to consider. Okay, what is this graph when we first look at this trying to make us see? Well, I would definitely say that this graph is showing us that it looks like almost 3 times, 4 times as many people in the Democrats supported the court's ruling, but significantly less Republicans and independents did. But if we actually take a closer look at this, we'll notice that this cutoff right here is at 50, not 0. So we're up here at 62 for Democrats, but we're only at 50. We're at 54 for Republicans. So we're only talking about a difference of 8, not 3 times as many, not 54 times 3 times as many. So actually not near as many people as it seems to be presented with. Okay, whose purpose do we think it is trying to serve? Well, this is probably definitely trying to show that more people in the Democratic Party are supporting this decision than other parties. Or maybe we're trying to show that Republicans don't support this at all, when maybe it looks like there's more support than there really is. So, if we wanted to present this in a better light, we definitely would want to make sure that we are always starting at our origin being 0, 0, which means we're not starting this cutoff in a weird place, but we are always starting that at 0. So, here we have a couple articles about flu shot. Does it make you get the flu? You can go in here and you can sort of look and see there's a couple different articles in here. Okay, it'd be a good idea to again pause this, click through, and read them. But if we look at both of these articles, we'll sort of see some different things showing up in here. Okay, of going through and seeing what you sort of might notice or what jumps out at you when you look at each of them. So, some things that I think would be important to notice. As we're going through the CDC's website, we'll notice that there's going to be links to other things that show us more on the research. So if we want to get more info, they've cited their sources, and we can go in and we can read more about where that information came from, right? We can look into how that research was collected. Whereas if we look at our other site, hey, we don't see that same thing happening in here. And again, I would suggest making some more time to actually go through and read that. I'm just not going to do it all in the video. Some other things that we might notice is that we have some very clear statements in here. Okay, this is saying flu vaccines are not thought to make people more susceptible, to other respiratory infections. Whereas we look here, you'll see a lot of things like why I don't get that. Here's what I think about it. Okay, this is a person's opinion on it. And in fact, if you do some more looking, you'll see some typos. That might be something that's a key element here. And if you do some more research into Dr. Phil Maffetone, you'll also learn that he is not a doctor of any type of dealing with health in terms of medical license, but he's a chiropractor. Right. So where is that information coming from? And is that degree in a place that, well, yes, it does have doctor in front of his name. Is that the type of doctor that might be giving us the best info on whether or not a flu shot is important? PlayStation 2 is the best video console of all time. Okay, so if we look here at this graph, right, it's giving us a graph about PlayStation 2 and how it sold the most video consoles. So there's some different things we might want to consider on this. We definitely noticed that PlayStation 2 has sold the most, right? Go down to Xbox One at the very bottom, right? A significant amount more. Who is this data trying to serve? Well, it depends on how it's being used, right? But PlayStation 2 and Nintendo DS definitely look good up here. But again, maybe we say, well, the reason the most PlayStation 2s were purchased is because that was around for a much longer amount of time. Maybe they broke more often, and so people had to buy more than one. Right? Some different options that we might have to consider there. Are there other things that could be pulling? Well, just like I said, other things that could be playing a role, such as right? The console broke. The console didn't work as well. There's different things that we could consider or say to ourselves as we're looking at this data. Screen time. So again, a couple other articles I would suggest you take a few minutes to go through. But again, you'll notice we have an article here that's about how the effects of too much screen time, what that has on your health. And then we have another article that's based on screen time not really being that bad. Okay, and what are some things that we notice? Some things that we might notice or want to be looking for is there any links to where that data was collected? Do we have any info about who the sample was? How many people did we ask? Right here we have some clear statements, just some basic statements, but we don't have any links to get any more of that information. You're likely to die earlier. Okay, studies have indicated that spending significant time with screens, whether it's a TV, computer, or tablet, lowers your cardiovascular health and increases your mortality risk. But is that a cause or is that a correlation? Right? Most likely that's just a correlation. It's just saying that people who maybe are sick watch more TV. But we don't have anything to back that up of how that data was collected. We don't know if that's done with an experiment. So those are some things we might want to consider as we are looking at those. On this last one, more than 7 times as many people died in motor vehicle accidents in Indiana than in Wyoming in 2017. Okay, so some things we might want to consider. Again, what is this data actually saying? Well, yes, we know that more people maybe died in Indiana than Wyoming, but what are some things we might want to consider? Well, how populous is Wyoming? Are there large cities? Do we have lots of places where people are all driving on a highway together? Maybe people are trying to, maybe it's serving Wyoming, right? Move to Wyoming, you won't die in a car accident, right? How was this data collected? Well, they probably just observational went through and pulled some things. We're not controlling for any variables. Did we look at all of Wyoming and all of Indiana, or did we just look at one big city in Indiana and one smaller city in Wyoming? We don't have any of that information in front of us. So these would all be important things we'd want to consider and to decide what to do with this data. So the important piece to just keep in mind today is as we're looking at data, we always want to make sure we're critiquing, analyzing, thinking about where data came from and what other factors might be in play.